Thank you. So hello everyone. This is it's my pet topic, along with corporate networking stuff, Active Directory. It's a really interesting topic. It's becoming less relevant as companies moved away from Windows dedicated environments and move more to cloud sort of stuff. And but pretty much any large company or even a small company is going to probably have an Active Directory still, and it's still going to probably be doing a lot of stuff behind the scenes. What is Active Directory? Well, Active Directory is, it's at its most basic, it's a database that holds everything to do with identity management in a Microsoft environment. So it holds the users, it holds the groups and all the permissions and the relations. It holds objects to represent computers, to handle computer authentication and policy. It can handle applications, services. It interfaces with pretty much any protocol you can think of, including LDAP is central to it. So it does user authentication. It does any authentication in every conceivable way, basically. The domain is, you can think of as the unit, the main unit, or like the overall unit in the Active Directory environment that holds everything. That's something like ad.monash.edu. You've got a DNS associated with a domain. Then in your domain, you have user accounts, groups, computers, and all that lives under domain. It allows central policy management and deployment. And it allows things like single sign-on and managing all your servers in a less cloud environment, but it also obviously integrates with cloud environments. The domain controllers are the servers that run Active Directory. These are really, really important machines to keep secure, because every domain controller has infinite access to everything in the domain. If you make a change on one domain controller, every other domain controller will replicate it. It's none of this sort of like blockchain, how many people do we trust? We've got to get at least 3 or 4 people. There's no two-factor stuff here. If you modify the copy of anything on a domain controller, that will replicate to every other domain controller. So every domain controller and its associated credentials is root in the domain. And along with things that are root in the domain, any admin account is root. And there are also some non-admin accounts, which, because of deep embedded flaws in how Active Directory is set up, are effectively root with like a few bits of like credential elevation, which is unpatchable. And Microsoft is like, just treat these accounts as root now, because it's like, we can't fix this. It's 20 years too late to fix that. On that note, you might hear, if you go into this field, something called forests, which are basically collections of domains and connections between domains. The idea of this was to have access control and have delegated administration, but Microsoft balked it. So now it doesn't work. So if you've got an admin in one domain, you can get admin in any domain in that forest. So forests are dead from a security standpoint. As I said, you can use Active Directory to do policies. So you can apply policies to users or computers. So when you log onto a computer and there's things like programs you're not allowed to run, the desktop background set, things are removed from the start menu, preferences are set. You can do pretty much anything using group policy. It's well, especially at least in older versions of Windows, some of the new telemetry stuff is not available through group policy unless you pay a lot of money for enterprise editions and stuff like that. And you might have heard people using things like group policy or the registry to modify settings in Windows 10 to customize stuff that Microsoft doesn't let you customize normally. The group policy is basically a easier and more scalable way of managing the registry on lots of computers from a central location. And finally, you can also have accounts for things that are not users. Like if you want to have a daemon running in the background or some other service you want to have running, you can give it a service account with the minimum permissions required. So with that in mind, actually, I'll just come back to that in a second. And so the thing you obviously need to realize is getting control of an Active Directory is pretty much having control over the entire network and everything in it. Because Active Directory, you get root and admin, or admin in Windows, but it's effectively root over every single computer, every workstation. It's like you got the CEO's computer, you can deploy software to any computer from Active Directory. So you can deploy your keylogger to any computer silently in the background, and the antivirus will ignore it because it's coming from Active Directory. That's trusted. You can access any data in big networks with lots of accounts. So often consolidate your account management into the Active Directory. So things like your routers and your firewalls will often use LDAP. Your printers will use LDAP to have the account management delegated to Active Directory, which means you can log into all those devices because you can add yourself into the permissions groups needed to log into those devices. So you can log into all the other servers that are connected to Active Directory. So it's a really pretty much an infinite level of access to get Active Directory, which is why Active Directory needs to be super, super, super secure. And it's why things like domain controllers are stored in physically safe locations, and you do not do anything on the domain controller. They're behind firewalls. You don't log into them except to do critical stuff. It's why you don't log into domain controllers or remote into domain controllers from your computer. If you're doing this properly, you set up a dedicated safe workstation in a locked room, which is used to log into the domain controllers, and that computer doesn't even have internet access. You treat this as the most important thing in your organization because it is. And hopefully Monash does this, but we might be able to find out if there's any horror stories later. Actually, I might have to cut that out of the video now. Oh no. Okay, so service accounts, as I briefly mentioned, accounts that are run not by users, but by applications. They might have elevated permissions. And typically, because if you're embedding a password in an application somewhere and setting up an application or device or something, the password's unlikely to ever change because that requires work, which means if you can break the password, you can potentially get a pretty privileged account. And so you want to try and set strong passwords because you're not going to need to enter this password, so there's no reason to not use just a random string. And you can do other things like disable the ability for that account to log in on computers, which you should do. Now, Active Directory has a long, long history with various hashing algorithms, and not all of it is great. In fact, a lot of it is pretty bad. So originally, Microsoft started off with the LM hash. This was incredibly reversible, incredibly weak. And then they decided we need to, and I think it had a limit of 7 characters. Then they decided we need to be able to have a 14-character password. So what they did was they took 2 LM hashes and put them back to back, but not as a 14-character hash, a 7-character hash, and then another 7-character hash. That's not as strong as a 14-character hash. That's 2 7-character hashes and much quicker to brute force. So that is really a really weak hash. And Microsoft realized this, and they added the NTLM hash, but they wanted to maintain backwards compatibility and stuff, so they had many issues there. And any environment that uses an LM or an NTLM hash is game over. There are so many tools that can pull it from pretty much any system. Unfortunately, if you're trying to hack in, but fortunately, if you're trying to protect a system, Microsoft has made things better in Windows 10. So for example, these hashes are disabled by default, and you have to because they're not needed in pretty much any system since like literally NT back in the pre-2000s. These have been out of date since pre-2000, but you'll still find them in environments that have been around since pre-2000s. The thing you need to understand is Active Directory came out with Windows Server 2000, and it was backwards compatible with NT 4.0, which became before that. That's a long time ago. That's a long time to have backwards compatibility in the security world. But things are being now, Microsoft is moving forward and breaking things by default in Windows 10. And then we've got more newer versions, but again, they're still pretty weak. And the other thing is, you can pass the hash with NTLM hashes, which is bad because you can just man in the middle, take the hash and then pass it on and authenticate to a server. So you can break the hash really easily, but you don't even need to break the hash because you can just pass the hash. So then we had Kerberos, and don't worry, this has had many CVEs and many patches over the years, but Kerberos is fundamentally a much more secure protocol because instead of just passing hashes around and weak hashes around, there is actually signing being performed by the domain controller. So instead of just sending a hashed password to an application server, which might be your file server or your web server on an intranet or another computer you're trying to connect to, what it does is and you can see the flow diagram here, we send a request to the domain controller, we get that, we send it across to the application server. The application server can choose to verify it, and then the domain controller will give us our access. So at no point is the password sent to the application server. It's all done through cryptography. But again, if we can get the keys that are used in this signing, which are from the domain controller, we can impersonate domain controller, we can sign anything, we can gain access to any server. So basically, one of the attacks here is we scan Active Directory for a user account with the service principal name that we want. Now, the thing you need to realize here is by default, any user account in Active Directory has massive, massive read permissions on directory objects. So you can basically find any other user account by default, and any computer account and any group. You have incredible read permissions. You can read all the policies, you can read some of the file shares on the domain controllers, because the way Active Directory is built, there needs to be this stuff available publicly. Now, this means you've got a lot of information. And so if you want to break that, that means you can see accounts that have privileged access from a unprivileged account. Now, from a practical standpoint, getting into an organization with, say, 60,000 users, breaking one account is pretty trivial. You can find a part-timer, a sticky note or anything. Getting into one account is pretty easy. And then you can, using that account, find which accounts you want to target to go further. So then what you want to do is basically request tickets from Active Directory for the account you want, and you can extract the tickets, and you can brute force the passwords offline. This is assuming you can somehow get the tickets and break the Active Directory. And I will share these slides with the links at the end. So that's the general idea. Now, this is where we come into a few other various protocols, which I'm not going to go into all of these. I'm going to focus on Samba or SMB. This is the protocol that file shares use. It's originally a Microsoft thing, but then they sort of open sourced the spec, and then this open source version it came up, and now it's become sort of the standard, but there's a long history there. Now, because it's used for file sharing on pretty much any Windows network for anything, there's a lot of these requests happening in the background, and it's based on the authentication protocols we've been talking about. It originally based on NTLM, the LM originally, and also Kerberos. And so if you can break that, this is authentication that's happening all the time, just in the background without the user even being aware. So it provides a really good attack vector. And the other thing is, a lot of important stuff goes over Samba, and by default it's not encrypted. So it's used for a lot of internal communication between domain controllers to workstations, and also just you access like your shared drive, a mapped drive on a file server or a NAS, and you're going over Samba. So there's a lot of data going across there. Even if you can't get, this is how they say, full admin, if you can break the Samba connection, you can still read all that data. Now, the first point we're coming back to now is, with a relay attack, using a authentication protocol like NTLM that supports the pass the hash or relay attack, you can just man in the middle, and no one will be the wiser, because it's an Active Directory. It's bad. There's not much more to say about that, except that you want to have Samba signing enabled, which is enabled by default in newer versions of Windows, which is nice to see, but there's a lot of old versions of Windows out there, and a lot of backwards compatible things that get broken if you turn off Samba signing. Like printers, for example, are a massive offender in this regard. A lot of printers are still sold that don't support Samba signing. So if you want to have scan to network functionality, for example, then you're forced to weaken your network or the server that that printer connects to be compatible. And so what can you do as a network administrator? You have to support that printer. So that's the problem with backwards compatibility. Now, this is just how you would go about using that. I think this is Mimikatz, but I'm not going to dwell on that because I haven't had time to prepare this. As I said, I am using heavily derivative slides. So two really useful tools. Mimikatz is ubiquitous in hacking Active Directory. A lot of antivirus programs will flag it because if you've got Mimikatz running on a machine, it's a good chance that you want to do something on that machine that's malicious. The thing is, though, it's open source, so you can recompile it and get past most antiviruses. So you really don't want to be relying on the antivirus to stop it. And again, crackmap exec is another very powerful tool, which, unfortunately, because I don't have a demo, I can't show, but it's also really, really powerful tool. Okay, I'm not sure what happened with that slide. So, dumping credentials, there's a few various locations that credentials are stored on every single computer. So, just going through these, the first are the system credentials, which are stored in the computer. Every computer has them, but they're more important in a domain environment because if you right click on pretty much any folder and see show the permissions, you'll see you've got a few groups added to the permissions for a folder, and one of them is system. It's the account that everything running on the system runs under. That's not a user account. And system is, well, you're running at the system level, so that's effectively as good as administrator. You can go from administrator to system and system to administrator. So it's a really, really high level of permission on a local computer. And that's where system level credentials are stored, including things like allowing that computer to authenticate as itself to the domain. And so if you can get that credential, then you can impersonate that computer on the domain. And if that computer on the domain has a lot of permissions, then that gives you a very high level user account, a very high level domain access. Then you've also got, again, the security and the SAM archives and the cache domain credentials. And this is, so this, the local SAM hashes. If you've got a user account on your computer, then that is where the password is checked against when you try and log into your computer. So on a non-domain computer, really, someone can pull the hard drive out. If it's not encrypted, they can just bypass the login anyway. That password is used to encrypt the credential store in Windows. So when you do remember passwords in Chrome, for example, that's encrypted with that. So you can't break the encryption, but you have got the hash, so you can try and brute force it, but it is more secure in modern versions of Windows. And so, but on a domain environment, you've got the local accounts, which can give you a lot of access. And again, this is why you should really have full disk encryption enabled, because otherwise a password is meaningless. But on a domain environment, you've also got cached domain credentials. So you have domain accounts, which are your user accounts stored in the directory. And when you log into one computer, you can log into any computer and with the same password. But if the network goes down, or you've got a laptop and you're outside of the network, you don't want the login to just fail. So when you log in for the first time, the computer stores the password, a cache of the password on the device. And historically, Microsoft did this in a really, really, really stupid, insecure way with weak hashes. Luckily now, again, not lucky if you're trying to hack it, but lucky if you're caring about security for your own defense, this has been largely fixed. The hashing is pretty much industry standard, state of the art. In new versions of Windows, there's lots of iterations using a secure hash. So that has been improved. And again, but if you've got local access, it still gives you quite a high level of access. And so that's just the commands you'd want to use with that. The LSA secrets. So yes, this is again more just domain credentials that are very useful to impersonate users and the computer and various other things. Again, insecure. Credentials are often stored in RAM, in plain text. This is again fixed to a large extent in Windows 10, if that's enabled or if it hasn't been disabled, depending on which way the default goes. But in Windows 7, you log into your computer and the password in plain text is stored in RAM. I think they might have actually pushed a security update to fix that a bit retrospectively. But if those on a computer that's not patched or a computer that had to disable it for whatever reason for backwards compatibility, having the plaintext password just sitting in RAM the entire time the computer's running is bad, and you can exploit that. Okay, this is a really useful tool, which is actually just better demonstrated by the diagram on the next slide. So if you can find a less privileged account and then find a path to a more privileged account, that's a really useful thing to do. And Bloodhound is a tool that will show you how to go from a less privileged account to a more privileged account. And so, yeah, that's an example of that. So you can find a low privileged account, then you somehow maybe get admin on a computer that can log into, then a high privileged account comes and logs in, you might do a keylogger or whatever on that computer because you've had admin to install a virus or whatever, and then you can go to a computer that has access to and you keep working up the chain, and that's a really big issue in Active Directory. So, Sharphand is another tool which grabs information from the Active Directory. Again, this is where a demo would be nice, but unfortunately I just didn't have time to set up a dozen servers and network it all together. But this is where we get to probably the most powerful attack and the ones you really need to try and avoid. Now, without going into too much specific detail about what the different tickets are, this is where we come back to how Active Directory authenticates clients through Kerberos and just between itself and everything. We have various tickets that the domain controllers have that they use to sign requests to prove identity from a user or computer to another device or to a place they're trying to gain access. If you can somehow get a silver ticket from the domain controller, you can start impersonating that domain controller. And so the golden ticket attack, and the difference is basically the level of privilege you can impersonate. A golden ticket has a higher privilege. You can impersonate anything on the domain because you're impersonating domain controller. Silver ticket has a bit more limitation of what it can forge, but still powerful. And so this is why you need to protect domain controllers and not have, say, a domain controller backup floating around on an insecure location. And you can do that with Mimikatz. It's a very powerful tool. And there are, I'm not sure if it's linked in there, so I'll add it if it's not. Great website, yep. So that actually comes to the conclusion of my prepared remarks. I'm happy to take questions. Active Directory is a complicated beast and really interesting, especially like, I guess 15 years ago would have been the heyday. Companies are trying to move away from Active Directory because it's such an infinite level of permission once hacked. But you can imagine any company with thousands of employees and laptops and computers takes a lot of time. And if you've got all your user accounts and all your permission structures and all that sort of Active Directory, migrating out is a lot of work. And there's not necessarily at the moment any great, I guess, single thing that does everything Active Directory does in the same way it does. Okay, some of the questions I've just missed. People who, yeah, so people, when I say not connected to the internet, you definitely want your domain controllers connected to the internet because you want to be getting updates. What you don't want to do is have like a browser installed on the computer. So yeah, it is a minority, I'm sure, but that's how it should be done. Windows is actually pretty, if you try and use a browser and domain controller, it will yell at you and say you shouldn't be doing this. The more subtle threat is someone uses a browser on a computer that they remote into a domain controller on, and then the credentials get taken that way. On the best practice now is actually to not have Active Directory passwords for domain controllers, not have admin accounts given to anyone, but rather the admin accounts are handled by an identity management system. You log into the system and say, with two-factor authentication, whatever approval process, and say, I need administrator for half an hour. Here's what I'm going to be doing, so audit purposes, and then it logs you into 15 minutes, half an hour, you do your thing, and then the access expires and it changes the password in the background. So it's secure. But again, how many people actually have that set up? I'm not sure. I don't know. I don't work at a massive multi-billion-dollar company. I imagine the big ones do. I imagine your average Active Directory wouldn't. Does PowerShell still work on Windows Server 2012 Plus? It depends what's enabled is what it comes down to. By default, things are more secure nowadays. But if you've got a domain function level of, say, 2008 or 2003, because you've still got computers that require to operate at that level, a lot of stuff will still operate. If you've got an old printer, or even not an old printer, my new printer that I bought last year still doesn't support signing. Yeah, it's potential that it will operate on a new environment because the backwards compatibility is there. Things are disabled by default, but the backwards compatibility is still there and supported. It's just a matter of if it's enabled or not. And the Microsoft is getting more serious now about being a bit more aggressive about changing the default privileges, but it's still a problem. And they publish everything like a year in advance, and everyone puts up a stink. No, this is going to break everything. And so, yeah, it's a slow process. Any other questions, comments? Might stop the recording now, or if you want to ask something that's not going to be recorded. Yes, Active Directory is so insecure by default. You install Active Directory on a new computer, on a new environment, and you install Active Directory in a completely new environment in a lab, and you'll get an error in the error log saying this security of this environment can be improved by doing these things. And then you do those things, and then you get more errors in the log saying the security of this environment can be improved by doing these things. And that's the things Microsoft puts in the security log. There are so many things that you don't understand they're insecure until you've spent hours reading the TechNet blog, or whatever Microsoft calls their blog nowadays.